So, welcome everybody. David Marcarian here, inventor of the MyoVision, and I'm going to talk today about the Davinci style interpretation. So what's changed is that I found the simplest way to look after all these years of coming up with complex ways at looking at the data. I found out that there's some really simple ways at looking at these patterns that exist. And I've simplified all this to make it easy for you, and also made some major changes in the software to make it so it's very easy for you to perform these tests and understand them. Now, one of the things that I'm going to bring up in this slide is, and I'm going to cover some background stuff before I go into the interpretation because I want everybody to understand this. When I say that how many of you are secretly working for the insurance companies without knowing it, one of the things that's been a real shocker is our gold standard up to this point has been the range of motion measures. And one of the things that's emerged from all these DynROM tests where we measure muscle activity and range of motion simultaneously, a process that I patented, is that we found about 40% plus of patients that have completely normal range of motion have muscle guarding and pain, and it becomes obvious when you combine the two tests. And then what becomes obvious, and we actually have a real case, went to court that established this, is that that range of motion data is being used against us when you find normal range of motion. And so we don't realize this, but the number of times that we see patients that have normal range of motion, and we've been fighting this uphill battle. One of the docs who does a lot of PIs, got I think about 40 clinics or 50 clinics that follow him. He started using the MyoVision about a year ago, and he told me, he called me about, I don't know, 2 months ago and said, "Oh, I finally get it." He said, "We've been documenting when they're in pain when they have normal range of motion by writing down that they said, 'ow.'" He says, "You're graphing the ow objectively," and that's exactly what's happening. So this is an example actually of this giant paradigm shift that's occurring where endpoint range of motion is being recognized. And John Gearhart, in his book on range of motion, the reason the MyoVision's in that book was after 12 years of testing, he also started recognizing that even though his baby, he invented range of motion in its current form, he was the guy who took it the furthest. The limitations were that you couldn't see that muscle guarding, and that was a serious limitation to range of motion. And he saw the same thing that I did, and that's why, after fighting with him for 12 years, he was gracious enough to include the MyoVision in the new AMA book on range of motion. But this is a real case. This patient had completely normal range of motion, and you can see 52 degrees inflection. Our test showed the same thing. So just so you understand what we're doing here, the bottom half of this graph is our range of motion being graphed. It's not endpoint range of motion. It's showing the graph of how they move. And there's a whole bunch of new stuff that's going to be coming out over this with regards to this, which is that when you do a graphed range of motion, you're showing quality of motion instead of just endpoint range of motion, which shows, when you see somebody ratchet, et cetera, you can graph that, and you can actually establish the standard deviation eventually in this and see how well they move. Now at the top, you can see the left is lumbar blue, left is blue, red is right, looking at the lumbar spine. We're looking at muscle tension. And we're graphing it over time. Now, this big, huge change, putting the pictures in, has made a huge difference in terms of how well this has worked, how effective it's been for getting everyone to understand it. And so in this particular case, we had the same range of motion, 52 degrees. That was the same range of motion data as the endpoint, but there was muscle guarding. So this case led to a $300,000 settlement. And you can see a normal when they bend into flexion, muscles shut off completely. So that's the lumbar spine. And again, this is an example of why range of motion on its own is not as valuable. It can be. Now, I just want to make sure you understand the basics here, because we're doing a lot of docs are getting deposed. They're battling with us. In the state of Washington, the second largest firm now, we did testing on some of the people with the attorneys there, and they are now doing a training class for all the docs that work with them, which is a lot in the state. I'll be teaching the class because of the fact it was so impressive how we could show specific different ranges of motion they had people had difficulties in, et cetera, and how well this could actually prove the case value up front. You can tell whether you have a good case or not, and they really appreciated that. Plus, they do feel like they've spent a lot of money on all different kinds of tools, on different kinds of docs, and the whole world is going to this evidence-based model. They recognize it, and they recognize the importance of it, and there's no better way than using the DynROM EMG for proving that. But one of the things that comes up is, I want you to know this because you're going to start getting questioned, it's not temperature. People get used to thinking that we're measuring temperature because of the thermography they learned in school. We're looking at a summation of all the depolarizations. It's the same technology as EKG, so we're doing the same thing as EKG technology. It's a voltmeter per muscle activity, and again, a summation of depolarizations. The attorneys are calling it the lie detector for back pain, the blood pressure measurement for the spine pain. It's seen that way, and remember, we're looking at muscle activity, not temperature. What makes it a secret weapon in the arena of law, of the medical legal arena, is the fact there's two kinds of tests. There's a static and dynamic EMG, and almost every attorney, every court up to this point, now we went to court, and this actually was established in a recent court case where this was used against the other side, but everybody believes that you did static EMG, and that static EMG is the only EMG other than needle EMG. But DynROM EMG, which is over 8,400 studies on dynamic EMG itself, we're measuring down here the range of motion, and up here we're measuring muscle activity as the patient goes into motions, and left again is blue, right is red. And so this is where it's a whole different kind of measure. In this case in Spokane, you can read it. You can get the court. We have all the court records and all depositions from now to the beginning, back to the beginning of time. I saved them all. It helps you for training. I have a doc going into deposition this week. He's been given every single deposition. He's read them all, the court records from the Florida case, and so it helps prep you to see the kind of questions they have, and it's available to everybody. But I don't want insurers getting it, so you have to email me for it. Anyways, this measure itself is a very effective means of establishing injury. And what you do is take advantage of it. Again, in this court case in Spokane, the IME expert witness wanted to talk about static EMG, kept bringing up static EMG. The attorney, who had been well-trained, asked a simple question, but didn't he do dynamic EMG? And the guy was stuck. He said, yes, but I don't really want to talk about that, basically. And he said, isn't dynamic EMG an approved diagnostic device in the state of Washington? And the answer, he showed him the WAC code. It's a statute, it's a WAC code in the state of Washington, and it actually has that information showing that it's an approved device, and he was shocked by that. But the point is that you take advantage of this, capitalize on this confusion. The fact that it's in the AMA's book on range of motion, which, again, everybody made fun of me for this happening, like it was the worst thing in the world for the chiropractic profession. Turns out it's the best thing in the world. We actually had a chiropractor go to court, a subluxation-based doc go to court in the state of Washington against this very nasty, mean, very smart IME, very, very well-established, and won the case because he walked in there with data. And you know who else would have done it? You know, as a reminder, B.J. Palmer was a big data fanatic also. He had tons of data, and he loved using machines. So the point is that this data, this book, establishes your credibility in the courtroom as a subluxation-based doctor because of the fact that it's the AMA is recognizing a chiropractic tool as a standard. And so, but the point is that we're not doing static EMG. There's nothing wrong with static EMG. You're going to see this is a wonderful tool. You're going to see it, you know, making a major comeback due to the fact that all the machines that didn't work very well are kind of disappearing, and the ones that work really well are still around, and the ones that work well do a very, very good job. So, but the motion EMG is what we're doing here, and so when you redirect them to this and point out that it's in the AMA book and has 8,200 studies on it, the attorneys change. They go, well, I didn't know what that was. I thought you were talking about the little bar graph with the little man. So that's critical, and I did create a great brochure. Dr. Greg Kramer is one of the ones that pushed me to do this. He was on, and so thanks, Dr. Kramer, and he actually brought this up too. One of the other advantages to the use of dynamic EMG, then the DynROM EMG, is that, and MRI is great, the measurement of ligament laxity is fantastic. It's just when it fails, you'll see that the DynROM motion EMG does establish injury in every case where these fail, and that's what we've seen continually. We actually had an orthopedic surgeon. We took 12 cases and we pitted the MyoVision against his MRI. and he called it, as far as surgery, whether it's needed or not. I did it based on the MyoVision. He did it based on MRI. He was off 40% of the time. I was right 100% of the time. This data correlated very highly with the Ross-Westry. This did not. And so that's a great example. I'm an example of where ligament laxity can fail. A year after my race car crash, 150 miles an hour, I showed no ligament laxity at all on the test that was done. And the reason was because I had such guarding, even though this test showed me abnormal, the ligament laxity wasn't visible. And so there's limitations that exist. Nothing wrong with these tools. They're phenomenal. It's just that when you combine all of them, you have some really good data. And what the attorneys like about this is an inexpensive test that takes the same time as range of motion. And what's interesting is it takes a little bit longer, around the same time as range of motion, and it pays about 5 times more. So it's been one of the reasons that people are actually interested in it too, is that it does work really well and it does pay for itself. It's cost effective. The AMA guides to impairment also point out that muscle guarding is equal to 5% impairment. Most people didn't know that. That's like a new one to most, but it's actually in there. And that has made a huge difference when you add to range of motion the muscle guarding. It's an objective test. It really passes the duct tape test. Attorneys love that. That means no matter, you're not relying on patient input. You're doing a test that no matter what the patient says, the data itself is independent of the patient's response. So one of the coolest things in the new software is in Feature Pack C is we have these little pictures that show the position of the body. What's funny about all this is this was in our software in the early 90s, which I think is really funny, but it's true. And we, by putting these pictures in now, everybody gets what's going on in these graphs. They used to be hard to understand. This made it very simple. This is just one of the many changes in Feature Pack C. One of the other cool things is, and I'll show you how to do this, we've added ideals so that when you actually bring up a patient and put an ideal next to them, when I did a presentation at these attorneys last 2 weeks ago, this is what it was that blew their minds, was I was able to show this. And the first question was, wow, or statement was, we can use this in the courtroom just as it is. And it's true. Here's what you present to the jury. And you just simply use this Add to Open Exams feature. It comes with Feature Pack C. You have to go to File, Import this, but that's done for you by Riley, whoever does the software setup for you, even though you can do it yourselves. This is the new brochure. It's an 8.5 by 11. It actually explains everything. This comes also with Feature Pack C. And I cover the court cases, how it works, the basic principles, and basically establish you as their best ideal choice for their soft tissue cases. Establish the DC as the best choice. That's one of the reasons I'm doing all this. So these are important tips for getting accurate data. First of all, make certain the patients bend forward in flexion when attaching electrodes. So that means that the skin's stretched out when you attach them. As you can see on the device, left is white, red is for the right side, white is for the left. White left, red right. Make sure they're bent forward. If they have trouble staying in the flex position, you can have them put their hands on a chair if you want to. Mainly so the electrodes stay on. Even though these are very good electrodes, the MyoVision electrodes are probably the best that I've ever used, and I've tested probably 200 electrodes. Have the patient perform 2 to 3 trials. This is crucial. 2 to 3 trials of each motion without measuring data prior to taking the data. So at each screen, have them do, like if it's a left rotation, have them do 2 left rotations and then do the measure. This is equivalent to what the AMA is requiring for that 10% between trials. What ends up happening is you end up doing 5 trials. So I just thought, well, why not just do 2 or 3 trials before you take the measurements, and they'll all be the same. And it's true. That's what ends up happening. It's because of a thing called the training effect that we learned in NASA, which is that you're going to have a training effect if somebody has to learn how to perform a motion, you have to show them, you have to get rid of that training effect so they perform the motion perfectly, and then you get significantly better reproducibility. It's really clear in the graphs. Make sure the patient's not wearing their shoes. Every time you test them, they want to be in the same state. Perform the patient, and when I say this, perform on the patient as soon as possible after an accident, I want to be able to gather data over a period of time, and so it makes sense to gather it as soon as you can after an accident. It still is valuable, even 2 to 3 months after an accident, but you want to track their progress over time, meaning you want a good baseline. Try to use the whole 30 seconds for the test. If you don't want to you always want to try to not do the test where you're racing them through it. If you're rushing them, you end up doing calisthenics instead, and we don't see this one effect which I want to see, which is when you return to neutral, you want to give them time to relax so we can see if the muscles do drop down when they return to neutral, because they should, and if they don't, it's an irritability that shows up, and it's important. So take your time, and one way to do that, when you bend forward in a flexion, for example, when they're in full flexion, count 1, 1,000, 2, 1,000, and then mark it. When you're doing the marking of these with the flex visions, pushing the buttons, mark at the bottom of the curve for flexions, count 1, 1,000, 2, 1,000, and then back at neutral, do the same thing, count 1, 1,000, 2, 1,000, to mark the bottom of the curve of the dynamic EMG graph for flexions and extensions. When you're doing lateral flexions and rotations, you're going to mark at the peak. So you're going to mark when they get to full left lateral flexion, for example, and then when they return to neutral, count 1, 1,000, 2, 1,000, and mark it at the valley, at the lowest point. So peak and lowest point for left and right lateral flexion and rotation, and then for flexion extension, just the bottom of the curve, the valley, the whole time, valley, valley, valley. Make sure to hold the inclinometers from the side. One thing that's hard to do is that John Gerhardt was a genius, and that he came up with this idea of doing the range of motion from the side. The reason it works so well compared to standard inclinometers is that we're trying to hold them from the back, and they're sliding all over the place. When you hold them from the side, get used to this. Lay your hands on the patient to stabilize the devices. Don't let them slide around. It makes it much easier. And now, to understand how to do this properly, go to myovision.com under support. You'll see videos on how to perform the test properly. And you can always go to support.myovision.com for any other questions you have on how to do things. There's a lot of support information there. So when you're doing here, we're showing this. When you want to make sure we're clear here is that when you're marking these, you can see how it's right in the middle. I'm not marking at the second they're at full flexion. I'm marking it basically 1, 1,000, 2 seconds into it. So we actually get a clear mark right in the center. You can see it clearer here. I'm marking it in their center of their full flexion and at neutral. And here's in our lateral flexions and rotations, you're marking it at the peak here and the valley here. So that's all you have to do is look for the peak and valley. I'm showing to use all 30 seconds. We don't want to do calisthenics. Don't race them through. You'll never see that relaxation occur. They're just moving too quickly. You got to have them stop at the endpoint in flexion and neutral. In lateral flexion, you don't have to stop when they get to the end. You just simply go to the end, mark it, come back to the center, and then stop. Here's an example of someone that didn't do 2 trials prior to doing the test. You can see how this data, you can also see the range of motions all over the place. If you don't do them, and you see this happen, if you don't do the 2 before, just toss this one out when you're doing your interpretation. Only use the 2 that are clear. But you can see test-retest reliability when you actually do 2 trials prior to gathering data is extremely good, in the 0.9 range. We do 3 tests in a row just to establish the validity of the tool. We're making sure that we show that reproducibility. If they're all over the place, you know, it's either the test technique's bad or, but I see this so rarely, and it's very difficult to fake this, but if you see readings going all over the place after 3, then it could be that they are. So now there's 2 kinds of motions we're going to look at. There's plane, which is flexion, extension, and there's asymmetrical, which is lateral flexion and rotation. So when you do these, you're basically going to look at a few different things. One of them, when you're doing a flexion or a plane motion, left and right readings should correlate well. So the tracers should overlay well. When you do left and right in lateral flexions and rotations, left and right should be opposite. So one side should fire without the other. So if you're doing a left rotation, the left might fire, the right might fire, but the main thing is there should be a big difference between them. In the cervical spine, it's the same thing. When you're doing a lateral flexion, you'll see readings fire on the same side for the CPs and the SEMs. In rotation, opposite sides. It's not important to remember this right now, but I'm just pointing out, you'll see these kind of patterns. When you're doing the cervical test, you're looking at, the most important thing to remember is we're focused on lateral flexions and rotations. The flexion in the cervical spine is not a really great measure due to the fact that it does not give you very much information. The cervical spine, when you're doing a flexion, kind of goes where it wants to. That moves different ways. It's not as clear. The lumbar spine, though, the lumbar flexion is extremely well established as a great measure, because as they go into flexion, there's only one way to do it. There's a lot of studies that show that the flexion relaxation response is excellent. We also look at the lateral flexions and rotations of the lumbar spine. But cervical, you're going to find the most valuable tests clinically are lateral flexions and rotations. And here you can see an example. We looked at our flexion in the lumbar spine, and here's an example of left and right cervical spine. Looking at the left side, this is our CPs here. Left is blue, right is red, so you can look at this graph. And the SCMs, left is blue, right is red. And so you can see that there's a good separation between both sides. And a lateral flexion, you can see the left side fires without the right. Now let's go through the interpretation. There's 3 cases for the lumbar. We're going to go through lumbar and cervical. There's 3 cases for the lumbar, and there's the way they work. We've got the normal, which when we bend into flexion, muscles go into complete relaxation. This is the left is blue, right is red for the lumbar spine. We bend forward. This is an initiation of the motion here. You can see by looking at the little man. And they're in full flexion. Muscles go into relaxation. And here's the range of motion at a peak. Complete relaxation and flexion. Because, why? They're hanging off their ligaments. We were designed, it's called a flexion relaxation response. It is a reflex for the muscle to shut off. The acute phase, we bend into flexion, and you can see we have good range of motion here, but both left and right sides fire like crazy. This is an abnormal due to the fact, and acute due to the fact that it fires so high. It's such a high voltage, and so the magnitude's high. Now we look at chronic. The muscles do not fire anything like the acute. They're right in the middle. They don't want to drop all the way down. They don't fire like an acute. They're right in the middle. So that's the 3 cases you're going to see in every. It's almost universal. I don't think you see anything but these. A scoliosis, you see a separation between left and right sides, but it looks like this with one side much higher than the other. That's the only exception that I've ever seen. Lateral flexion and rotation. What we're looking at here is there's a big separation between left and right sides in a lateral flexion. So this is a lack of guarding. More space. The key to remember is not to look at which side fires when you go left or right. It doesn't matter. All you're looking for is a space between these. If there's a lot of space, good. No guarding. Think of it that way. They're going one direction. The other side doesn't engage. It means there's no guarding, which means you've got a normal. Moderate, it fires about halfway. You can see how both fire, but there's not a great amount of space. Acute, both sides fire simultaneously. That's our lateral flexion and rotation. It's just showing an example of what we use in the courtroom, normal, injured patient. You can see the difference here side by side. So cervical exams. We're looking for the lack of correlation between these traces in the cervical spine. We're not interested in, even though flexion relaxation is a part of it, it's so difficult to really establish in the cervical spine due to the fact that the flexion in the cervical spine can occur in so many different ways. But what we're looking for is a separation between these traces. These traces should follow each other perfectly. It should be overlaying each other almost perfectly, very similar. So this big separation is what concerns us. This is an indication that there's injury. Now, in a lateral flexion and rotation, again, we're looking for, ask that question, is there a lot of space between the left and right sides here? The answer is no. That means we have a guarding state. Is there a big space between these two? Yes, that means we don't have a guarding state. So this person, this individual's issue occurs and their guarding response to injury is in the CPs only. The cervical paraspinals, the SEMs are firing just fine, relatively so. The fact that these are details that are irrelevant. You see this is them pulling them back up, but the response is actually relatively normal. The CPs are the problem. So what we have now with the software, which is really cool, is you can put them up on the screen together, ideal versus patient. And here we're showing it again. And you can see that when you show them this way, it's really obvious. You can see the space between these is great. that's no guarding. This is guarding. And again, keep it simple and you won't have to worry about it. Now the software does export, the new software Feature Pack C does export the data into a report. It gives you the AMA normal range of motion, etc. And we're going to go through and look at that afterwards. Right now we're going to continue with this cervical lateral flexion and rotation. Again, you see good separations good here. Now the key here is in lateral flexion, the same sides typically fire, even though we're only interested in the difference. I'm just pointing out this little subtlety. You'll see in a lateral flexion, the same side, this is blue in this case, the left side fires in a left lateral flexion. And then when you do, this is showing what happens in a left rotation, that the CPs fire, left is the left CP, red is the right CP, while the SEMs, the opposite side fires. Obviously, the opposite side fires to stabilize. This initiates the motion with the left, and this fires to stabilize. Otherwise, your head would spin off. So let's go quickly through some examples here. This is a motor vehicle accident. This is a patient claiming full disability. This is one of the examples. We did a presentation to all the PI attorneys, state of Washington. Attorney came over afterwards. I took about 5 cases on about 4 years ago. I've taken on a bunch of cases, and it's interesting how all of them have come to fruition in great ways. This is the one where he asked, I said, if you wanted me to testify that this person I wasn't going to be very helpful to them due to the fact that with all the grunting and groaning, this is one of those rare symptom magnifiers. And this person was in so much pain. There's video of this, and they're going into flexion. The attorney, by the way, said that I would have saved him a huge amount of money if he had just listened to me, because they ended up losing, and he had to pay a lot of money in the process because it was a $5 million case. And he lost, etc. Here's a normal bend into flexion. Here's the patient bending in flexion. Is this normal? Yes. A lot of weird things going on here, but in the full flexion position, you see no injury at all. This is normal. Now, even if the person's on opiates, the opiates do not influence this, as far as I know, or I've seen any research on it, does not influence it at all. It's a central nervous system pain reliever. It does not affect the actual muscles, so they still go into fire. They're firing no matter what. Here's an example of the normal. This is a left lateral flexion, normal, big separation. See the same thing here. There's some irritability here, but overall big separation. So again, we just have to focus on the difference. Get rid of all the complexity to it. Make it really simple, and it'll make sense. Again, we look at here's a motion. Now again, doesn't matter which side fires. There's a thing called paradoxical firing where the left side fires in a left rotation on some individuals, and others it's the right side that fires. No one's ever quite figured it out yet why that happens, but what it does, and the key is, instead of looking at which side fires, look instead to see if there's a big separation between left and right sides. When you get more advanced at it, you will make sure that you compare left and right motions. So if you did a left rotation and a right rotation, they should fire on opposite sides. It should look like this. But the thing to remember again is just the space between them is how we tell whether there's guarding. No guarding, no guarding. So this would be a conclusion that this person's not injured. This case was an individual, and this is something I've seen more recently too, and this is, again, one of the things that made the DynROM so valuable, is that this case is an example of somebody who had such a high tolerance for pain that he appeared relatively normal to everybody. The IME, everybody looked at him and was like, what's wrong? This guy seems completely fine. He's not in pain. He had good range of motion. I had one recently, young woman who's in great shape physically, seemed to be happy, no issues at all, but was in a lot of pain, and her tolerance for pain was extremely high. And the graph, again, matched exactly what she was feeling. Here's the individual, normal, again, bending into flexion, muscles shut off in flexion. These are 3 in a row. Muscle shut off, left is blue, right is red, so range of motion. Here he is. You can see in full flexion, muscles fire like crazy. This is an injury. Again, we look at lateral flexion. Good separation means no injury. This is no guarding. You can see guarding. Both sides fire almost the same. So that's why we want to look at this, is we're able to establish if there's a guarding response. Okay, you can see that this is a moderate. So he had more trouble in a left lateral flexion, in lateral flexions than rotations. The rotation looks almost completely normal. It's kind of a moderate, but it's not a real problem. So let's look at the cervical example. This is a recent case. What we're looking at here is ideally the traces should follow each other. This is not necessarily what you find all the time, but the key is that traces should follow each other nicely. And in this particular case, you can see the patient bends forward in flexion. You can see how the muscles fire completely different as they return to neutral. Any separation is what we're looking for. Is there a correlation of these traces? If it's low, that's bad. So you can see here in the SEM, same thing. As we're doing flexions, you can see that there's a tremendous separation between left and right sides. That means that this is most likely due to injury. It's an abnormal muscle response. In extension, same thing. There's not a lot of data on extensions, but in theory you should see the same kind of thing where they should follow each other nicely. You can see big separation here. Looking at lateral flexions, just so you remember this, just to remind you, the cervical paraspinals at the top, the SEMs in the bottom. So good separation left and right means that there is no guarding. And we can see in his situation here, in his case, he's actually, this is in a left lateral flexion. You can see it's pretty good. There's not that much guarding here. There's some, but not that much. So he's okay. Range of motion is pretty good. And again, normal. We can see that, oops, look, what do we have here? See how our SEMs are firing together? So the muscles that are guarding in this motion for him are his SEMs. The cervical paraspinals are doing their job relatively well. You can see some recruitment here that's occurring that's a little bit abnormal, but the overall we focus on is there a big difference between left and right sides? The answer is no, there's not. That means there's guarding here, here, and here. That's an abnormal finding. And now we look at rotation, and again, is there good separation like this normal? No, absolutely not. Definite difficulties performing a rotation, 3 in a row, and you can see the SEMs are doing their jobs relatively well. Good separation. Now, one of the coolest things about this, and this is attorneys have been telling me this more and more lately, and it's been interesting to see, there's the machines, there were 9 different machines, 10, 12 years ago. There's I don't know, there's 1 or 2 left, and that's it. And it's been interesting to see that the machines that are working really well are doing an excellent job. That means that this is getting back to attorneys. They're hearing really good things about the static and the dynamic. But one of the most important things, and everybody forgets this, is that it reduces the stress on patients significantly to actually have something objective to validate their complaints. Why? Because when you don't have a broken bone, you have nothing to show for why they're injured or what the cause would be. No one really believes you after a while. They think you're faking. I know this from having a race car crash that I learned to empathize when I found I was in so much pain. It was ridiculous. Although I didn't look like it, per se, I had nothing to show. A lot of people were very skeptical. And this has been helping attorneys. They can tell whether the case is real or not, and it's been a major reduction in stress for the patients. It's amazing how many calls I get from patients thanking me for inventing this, because finally they can show their family and friends and their attorney, everyone, that they're actually really injured, even though they don't appear to be. So that's one of the best byproducts of using this. Just want to point that out. So I'm going to tell you a little bit of some of the software features so you know. I'm going to show you how they work. We're going to actually go in and show you in the system how they work. The eScan, you guys probably know about it. It sends tests to your phone. I like it because the patient actually gets to receive the test and gives instant feedback to them. Again, it gives validation to them. It's great. It's your electronic business card. They're posting it on Facebook. But in the dynamic, what we've done is the body images being in the graphics, male and female. The interpretation report is really great because you can actually right-click and export it. I'm going to show you how that works. Now I'm going to show you how to change some of the cool little features. You can change the line width in the graph so they look better for you if you want to, and the size of the images can be changed. So you can increase the size, small, medium, large. You can actually change the number of images that you put on the screen. So actually, let me switch over and I'll show you what this is like. Where did it go? here. So if we go in here, showing you how the ideal works too, let me do this quickly. If you want to show a patient next to an ideal, let's say we open, we're going to close this, we open a test. I'll pull up an abnormal lumbar test. So we pull this up, we have this up on the screen. Now to get these in, and once you've installed Feature Pack C, you're just going to go to File, Import, and there's instructions how to import these from the C drive under WinScan 98. That being said, once they're imported, all you do is go Open. You can type the number 1. It'll take you right to the ideals. So here's ideal, and we'll pull up the lumbar one. You can double-click it. You can hit OK, or double-click. It'll ask you if you want to replace or add to open exams. You want to hit this, Add to Exams, and it shows them side by side this way. Your ideals here, and you have your patient here, and they're live, so you can actually go to each one of these and compare them. This has been the most impressive for attorneys to see it this way because they have them side by side and they understand it. Where you turn this on, go to Setup, Settings, General. You want to make sure that this is checked, Show, Add, Replace Exam Prompt. So it actually allows you to put them on the screen. You can also put on more. You can open up a bunch of tests up to 9 and show them on the screen at once to show progression. And the way you do that is if you select a bunch of tests, you can take a test, for example, you can take all of these and you can say you can hold the control key down and select the test you want to see and put them on the screen by clicking OK and then add to or replace. So for example, if I want to see 4 of these, I can go like this and I can show them on the screen at once by saying replace open exam, and that would put them on the screen at once. Also, to change the line widths, I want to show you this because you can actually do some stuff with this. Here you can see, and they're all live windows. They all work. They're not just pictures, and you can actually increase the size by clicking the minus sign, the larger box to make them the main focus. But you can also go here. I'll show you where you can change the line width. Setup, Settings, Dynamic. The standard is 5. If you want to make it a little bit bolder, you can make it like a 7 or a 10. And you can also see a preview of it. So you can change this, and as you do that, you can preview it and get bolder and bolder looking lines. So I'll turn it back to 5 for me. I do that for a lot of different purposes. And then as far as the pictures go, you can go to Dynamic ROM. You can turn on which ones you want to see. Like I can turn off the neutral images if I want to and just show the motions. And I can select medium, small, medium, large. If you're going to print these to a PDF, I'd recommend using Qt PDF. It's a free software for generating PDFs, but you want to use the medium at the largest. The large ones do not, they look good, but when you go to print, it takes up too much space on the screen and it kind of messes things up. So use medium at the largest for that. And so that's some of the couple things that you need to know about as far as using the software. And then let's see, we have, again, the ideal. We've shown you that. It's very cool. The Simplified Guide to Interpretation, there's a whole new version of it coming out next week, but you can actually get this now. If you go to myovision.com and you go to myovision.com and /success, I believe, you can fill out a form, send that, and they'll send you this guide and the rebuttal that was written for this legal case recently. And also, so here you can go to myovision.com, fill that out. The brochures that are new are also out now. You can actually order them. They're on the store at store.myovision.com. Some tips, some tools to enhance your experience. TechSmith Saget is a great way to snag images and add graphics to them if you want to. That's how you can add those little, if you feel like doing snagged images and drawing on them and stuff, you can use Snagit. It works really well. If you want to, if people are, everyone, I'm sick of it, turn Windows 8 into Windows 7 as far as putting the start button back, you can go to support.myovision.com. You can go to the support site. I'll show you what you want to do, support.myovision.com, and you'll see by just typing start menu 8, it'll take you to a place that tells you exactly where to where you can download it. Right here it gives you a link to download it, and you can install it, and it actually puts the start button back. It's kind of nice. For research, MyoVisionInfo.com has a bunch of research. One of the big surprises recently, the largest organization that determines policy as far as workers' comp has changed their policy with regards to Surface EMG. It's the biggest shocker. It happened about 3 months ago, and they no longer, if you read it closely, they're hoping again that you don't know the difference between static and dynamic. They're only questioning static EMG. They're no longer really questioning dynamic EMG. But you can get all this information on responding to any insurance issues. I've been really good about fighting them, which is why reimbursement's been excellent. If you need video training, go to myovision.com under support. You can see how to do things. QPDF Writer, you can Google this. It's a great way to generate PDFs of test data. I'll do it so that I get the graphics, and I'll actually generate the graphics in a QPDF so I can send them off to the attorney, and then the report itself. Now, as far as generating the interpretation report, the way that works is you right-click on the screen anywhere and go to Interpretation Report and left-click on it. It opens up in this Word doc, and all you do is go through it. It's very nice. Now, by the way, this is a template, and it's using Word. It was actually a really great idea that I came up with, was to use Word instead. So you can actually make this template say whatever you want. You can change the wording, save it in the right spot in the computer, and then it'll always select the one that you want, your own template. You can save your signature in it so that it actually puts your signature at the bottom automatically. It's a great report, though. It explains everything that happened. It shows how the test was performed. It gives an idea of what normal looks like, what you'd expect in rotations and lateral flexions, and all you have to do is switch back and forth. You can see I was doing one of these. Switch back and forth between the test. You can look at it, for example, this is the wrong kind of test. It would be a lumbar, but regardless, you look at it and say, oh, that's an abnormal test. Go back here and select each one of these drop-downs. It takes about 5 minutes to do each test. So for each one, you'd say they're normal. If you didn't like that, you can actually go back and change it and save the report. You can also put your conclusion in here, and you can, again, put your signature in here and save it in the template, and then you can save this as a PDF and then send it off. Now, this report does not have graphics in it for a reason. It does have the AMA normal and the patient in it. It does not have graphics because we don't see graphics in the MRI reports. We don't see them in any kind of other tests that are done. Radiology reports don't have graphics in them, so we're not doing them either, and they don't need them. So this is your report. As far as insurance reimbursement goes, you know that I believe the CPT code is it's only a chiropractic tool. It's one of the arguments they make. Well, it's in the CPT code book. 96002 is dynamic EMG 0.54. The report, which you can do in 5 minutes, is 96004. The average doc is telling me they were able to bill about $250 a test. That's what I hear anyways. I'm not here to tell you what to do, but this is about 50 to 75, and this is about 150, I guess, and that's what they come up with. And so, like I said, it takes about the same time as range of motion, slightly longer. And so there's a cost upgrade depending if how old your system is. And just so you know, the reason is it's not a software update. This is a major change. The whole concept, the MyoVision concept, has been since day one to build a very solid hardware platform and to future-proof your system with software. Those that know about the wired system, 20 years it was supported. You don't see that for any equipment anywhere. It doesn't exist for cell phones, doesn't exist for computers, and so there is a charge. It's not a lot, but part of the reason that we're charging for it is that I have to go out and win these court cases. I have not lost a single one yet, taking all the insurance companies in the state of Florida all the way to the Supreme Court. You can imagine that your costs can go up quite a bit. But that helps you. It helps establish your credibility when I do these. So I can't get away with. I'd love to give everything away, but I can't. The other thing is now one of the best things for you is I'm integrating this now. All the schools have requested MyoVisions in pretty much every school except for maybe 2, and they want to integrate them into the schools. And so part of this is very expensive to do. I'm doing them at no cost at all. I want these students graduating so they know how to protect their right to practice, and when they come to work for you as an associate, they'll know this stuff forward and backwards. And so that's one of the other reasons. So I'm just want you to be aware of that. You pay a little bit of money for the software, but you end up with this complete new product. Software updates, though, are free for a year. Those are the ones where we're making bug fixes and changes that are minor. But major upgrades like putting the interpretation report is very expensive to do. I don't want to leave you hanging without developing new stuff. I want to continually develop new stuff, and it does cost a little bit of money. So. And if you do want to upgrade to the new software, if you have older systems, you can, as your systems are newer, you can contact MyoRep12 at myovision.com, Riley, or call the toll-free number, and you can select one for sales and then go to, I think it's 2 for software sales. But if you put the DynROM coupon code in at store.myovision.com under Feature Pack C, I think it saves you $100 for the software. And the attorney, you get 25 of these brochures for free. Also, these are on the store right now, and they're really just basically at our cost, but it's great educational materials. They're 8.5 by 11 brochures, and so I point out here that everybody has a warrior. Everybody's a warrior here, and Service sEMG is really a great weapon for the DC of the future, and except for it's available now, so make sure to use it. Any questions for me? Let's go ahead and see what kind of questions we have. And thank you very much for being on the call. So let's go to see what questions I have, and I'll try to respond to them here.